Hello, and welcome to the OpenSlice tutorial. I'm the Technical Steering Committee Chair, OpenSlice, Kostis Transas, from University of Patras, and with me today are the TSC members, Rafael Direito from IT Aveiro and George Katsikas from UBTech Greece. So I'm going to start with some brief OpenSlice introduction and the highlights of our latest release, which is 2025 Q4. As said, if you are not familiar with OpenSlice, this is the introductory slide to get you familiar with what we do. So OpenSlice is an open source operation support system. It has been working as that prototype for quite many years to deliver network as a service, always in accordance with specifications from major STOs. Since 2023, it has been operating under the umbrella of ETSI, forming its first software. The original idea of OpenSlice was derived in the context of EU-funded project 5G back in 2019, and since then it has adopted and received contribution from several other projects along the way. OpenSlice tries to complement other activities within ETSI and other principal SDOs, such as TM Forum, and always tries to facilitate prototype, experimentation, and validation of the introduced telco use cases. It tries to provide early experimentation and feedback to the standardization group so as to contribute towards higher quality standards. So in essence, let's see what OpenSlice does. We all familiar with this, I would say, architecture more or less. So we have the network spanning for far edge to public cloud, and we suspect that every part of the network is implemented or exposes programmable controllers. These controllers is not what the user expects to see, and users are more familiar with APIs coming in essence of catalogs and blueprints ready to be ordered, and also through UIs, which would essentially consume the respective and exposed APIs. An API that it is known in the telco world and is as expected to be seen is the TM4 APIs, exposing services, catalogs, and products. And so the order specifications are processed through an end-to-end service orchestrator, which consumes the exposed APIs of the network itself and provides the end-to-end service. This end-to-end service is exposed and consumed to the user, which ordered it. So OpenSlice stands within this box. It offers the exposure layer through TM Forum-based APIs and UIs. It also integrates its native end-to-end service orchestrator that brings forward these specifications into tangible results, consuming programmable control. This slide presents the collaboration with other open source communities, and as you can imagine, OpenSlice is highly involved within ETSI, along with its open source components, which are open source Mano, TerraFlow, SDN, and OpenCapif, but it's not limited there. It also tries to integrate specification and provide feedback to standard defining organizations as well. So within ETSI, it has been exchanging ideas and participating to the NAV ISG. Also, it follows the principles of the ZSM and also is being a part of some POCs in ZSM. And last but not least, it follows closely the Autonomous Networks OCG, which also contributed within its latest white paper, AI for Autonomous Networks. As TM Forum comes into play, we participate actively in the Open Digital Architecture Production group, which specifies the end-to-end flow and architecture of TM Forum, and also are monitoring the activities of Autonomous Network Strand. As you see later on, it is of high interest in where OpenSlice targets to be. Last but not least, we follow software and approaches from the Linux Foundation, and specifically Silva and Camara, and we have POCs proving that, and one of which we shall see today. So trying to aggregate the overall ecosystem of OpenSlice, as you can see, OpenSlice started and indeed operates within the context of European research projects. As you can see the logo, starting with 5G Bini back in the day, spanning to the contemporary projects of Horizon SNSJU. But also, as you can see in the right, on the left side of the picture, it integrates standard and tries to provide feedbacks to major SDOs such as ETSI, TM Forum, CSMA, 3GPP, and the Linux Foundation. So this is the introduction, a brief introduction, just to get you to know the software, and now towards the latest release. The latest release was made available at the last week, 25th of January, and as we typically do during releases, we have had the first announcement of the release in the OpenSlice web page. We have also made available the release notes, so you can see what changed at every component. We have the software documentation as well. And if someone is interested in the development phase, you can track the release epic with all the issues that were resolved. Last but not least, the code is already tagged. So for those that you are familiar, you can use the latest Docker image tag to download and play along with the latest release. Some highlights from this release, apart from the recapping numbers, as you can see in the right part of the screen, we have some highlights on the outstanding features that we have developed at this development circle. So far, this is the most, I would say, development-friendly, development-heavy release, and we are proud to present these features to you today. The first feature that enables the AI part of this release is the MCP backend. The MCP backend is a lightweight service that connects to the already existing OpenSlice MCP server, and it tries to introduce a local LLM via the Ollama API, and also expose the results in two ways, one RESTful interface and a message bus connection. So what MCP backend is the first OpenSlice agent. A feature that was enabled by the OpenSlice MCP backend was the AI assistant. So as you may have seen since the previous release, we have integrated with external MCP clients, but now it's a time for OpenSlice to engulf its own AI assistant in the UI, which connects to the MCP backend and offers reasoning and calling functionality to the user. Another issue that was made available through the MCP backend was the agentic orchestration, or an orchestration that is enabled and augmented by the usage of AI agents. So now the orchestrator, awesome, can invoke agents during the orchestration lifecycle. And this agent can span from simple input, reasoning, and also tool calling, closing the loop. AI aside, we have also implemented new add-ons and controllers. So we will integrate more controllers at the southbound of OpenSlice. And the first controller is GitHub. And as the name suggests, is a controller to follow the GitOps paradigm and Nokia's network as code controller. Um, as we had the controllers and the AI side, we wanted also to augment the open digital architecture exposure. So this is the reason that we have implemented and extended the TMF product UI within OpenSlice, trying to capture the product design and prototyping the product ordering. When it comes to OpenSlice functionality, when being the administrator of the installation, we wanted also to enable some observability features when someone chose and opted the Kubernetes deployment. So this is the reason that we have created a dashboard to visualize OpenSlice metrics and logs. Last but not least, to lower the entry barrier of newcomers, we have designed a repository that will host indicative service packages. And this first release fosters one, which deploys a 5G core with 2 simulated subscribers. And this repository is aimed to host ready to be imported and deployed services with minimal intervention. So when it comes to the architecture enhancements, as in this latest release, the upper part remained unchanged. So the upper part is split by the left side, which is the exposure layer of OpenSlice, which are the APIs that the software expose, the TMF ones, and the NFV, along with the respective UI. The right part fosters the typical microservices that the service or a software, contemporary software hosts, which is the authentication and the authorization service, issue management, logging, and assurance service. What really makes a difference at this release is the lower part under the service bus, which hosts the OpenSlice Service Orchestrator, or OSOM, also augmented with AI capabilities. The AI layer, which is extended along with MCP server, now comes MCP backends, which consumes the MCP server, also enabling local LLM deployments, and also all the OpenSlice controllers, spanning from the oldest one, the NFV one, to the Kubernetes controller, to Prometheus, to Silva, Camara, 3GPP, and now GitOps and Nokia's NAC controller. So starting from the first feature, this is the MCP backend. And we're proud to say that this feature is what brings OpenSlice in the agentic AI era. As you may know, since release 2025 Q2, 6 months ago, we have included the OpenSlice MCP server, which offered functionalities such as service catalog browsing, order, and inventory as MCP tools. We have then connected to external AI assistants, back in the day, the Anthropic's Cloud Desktop, exposing OpenSlice functionalities through a chat window. There is also a video that you may follow and linked in this presentation and see what we had back there. But we couldn't wait and stop there. So this release brings this new component, the MCP backend, which is OpenSlice solution towards native agent, including frugal AI and sovereignty. So what this does is integrates with a well-known service to host local open source LLM, which is Olama, and the user can feature different open source models running within Olama and connect this to MCP backend. At the same time, it connects to the OpenSlice MCP server, also getting access to all the OpenSlice tools. As it comes to exposure, it connects to the service bus, primarily offering agenting functionality to other OpenSlice components internally, but also it offers a REST interface, which can be leveraged by external chatbots, but also for the OpenSlice AI assistant natively integrated within the UI. Last but not least, what this does with the connection to the service bus is that it enables agent-enabled service orchestration. As Awesome, the OpenSlice service orchestrator can now integrate and interact with MCP backend for complex decisions that were not foreseen in the initial predetermined orchestration flow. So towards the first feature that the MCP backends enables is the AI assistant. As the name suggests, now the UI of OpenSlice integrates this new assistants that you can find at the top right part of the screen. And it connects to the MCP backend, so it gets access to LLMs. And at the first release, we prioritize in LLMs that were locally deployed for sovereignty and efficiency, and also to the OpenSlice MCP server, exposing um, OpenSlice tools and their respective functionality. Something that is crucial about this feature is that we have not neglected authorization and authentication. So the user authenticates through a familiar UI, which is the OpenSlice UI, and the authorization context is passed through the UI towards the MCP backend and to the MCP server. So now, when someone uses this AI assistant, we know which user he or she is. So we made the respective orders and actions towards its name. And also, this AI assistant can keep the context and the session. In short, it has memory. So let's see the first demo of this day, which is a video of the AI assistant in action. So as you can see, at the top right part of the screen, we can navigate the assistant, and this is an working OpenSlice instance, a production one, and you can see that the user requests a Kubernetes cluster. So the system presents of the options, and as you can see, it gives the user three options, and a standard Kubernetes service, an AI one, and how to join an external node into an existing Kubernetes node environment. And as you can see, these services are existing, are the ones that are already exposed in the OpenSlice catalog. So the user will now opt for a standard Kubernetes environment, being the one that it was the most difficult to derive out of this context. Bear in mind that this video is unedited, so these response times and thinking times are real. So what the chatbot returned to the user is that now the user can affect some parameters. And in this case, it can affect the number of worker nodes wanted and also the flavor of the worker nodes. So the user at that stage opts for two nodes with the medium provided flavor out of these nodes. And it takes one step further, asking also for an duration over this order. So this answer is fed towards the chatbot, and indeed the indicative service order is created, and the user is returned with the order ID. As you can see, this behind the scene, this enabled indeed the service order API and place the service order by the username, as we've said previously. This this order is in progress, and 10 minutes later, the user can query about the state of the order. Um, Interestingly enough, this was the most lengthy query to be answered. To be honest, a bit. I think it was 20 seconds or so. So the chatbot eventually returned that the order is completed, and the user can navigate to the UI to get the respective kubeconf of the cluster, so he or she can have access towards a newly deployed cluster. So that's it regarding the demo. We've seen, maybe you are aware and familiar with how OpenSlice operates, and the UI was the only way to issue orders and preview them. But now we offer this co-design UI that would enhance the user functionality within OpenSlice, offering also another interface to query things. Now moving to the actual and the most fascinating enablement of the MCP backend, agentic orchestration. So today, orchestrational decisions within OpenSlice were based on predefined and repetitive orchestration flows defined via a business process diagram. This could be described as a level one autonomous system, as TM Forum defines levels of autonomy. So it is an assisted operation and maintenance. As you may know, OpenSlice could offer also dynamic orchestration and let user define orchestration flows or no-code orchestration flows that were injectable into the orchestration flow during runtime through Blockly. So this is layer two of autonomy. So this was a partial autonomous network. Now, what MCP backend brings into play is the agent-powered orchestration via agents with tool calling enabled. And this indeed moves us towards layer three and layer four levels of autonomy. So how this orchestration is delivered. Several agents may connect to the OpenSlice service bus, not just the MCP backend, and they advertise their names, so they listen to specific cues. This agent can integrate LLMs, so they can have reasoning capabilities, and optionally, they can invoke also tools via connected MCP servers. So the MCP backend is a native OpenSlice agent having both functionalities. Now, during orchestration, OpenSlice Orchestrator, awesome, can call agents throughout all the orchestration lifecycle. And this connectivity or this connection and invocation happens through the service bus, talking to the specific queues that several agents are listening. So let's assume this concept. We have a service bus of OpenSlice. It fosters different agents. And as you can see, starting from the left, we have agent X, which incorporates a local LLM, which is a conversation agent. We have agent Z, which is an agent that incorporates, again, a local LLM, but also integrates MCP servers. So it has the tool calling capability. And we have also agent Z that integrates with remote LLMs or the commercial LLMs, as you may know, from OpenAI, Anthropic, and Mistral. So these agents reside and live on OpenSlice service bus. Now, we expect that a service order can invoke several characteristics or would assume the user to provide several characteristics. And in that flow, given the characteristics, we can ask the simple agent X for some reasoning, So we can augment these characteristics and apply some reasonings towards characteristic action. Then, towards the newly introduced characteristics, we can split the logic between the more capable agent Y and Z, so that this reasoning, the new reasoning, can be resulted into specific actions through the MCP service integration.
So for that, we don't have a demo because we wanted to have you waiting for something, to be honest. But we have a proof of concept that would indicate how this works. So let's imagine a service. It's not a service. Let's imagine a capture of a high level user intent. So this is the intent, to deliver a high resolution sports media experience with connected devices via 5G with specific real-time functionality and statistics. So this is the user input. What we expect to see here during the orchestration logic is a suggestion towards specific products that realize this high-level intent. So we have two types of agent. We have the first one. It is a simple, I would say, agent integrating an LLM, which, as you can see, it's not that capable. It's 8 billion parameters. And we have the second agent, which integrates a more capable LLM, also with the OpenSlice MCP server. So it has access towards OpenSlice resources to perform actuation. So the logic is the given. Assuming that we have the initial high-level intent, we delegate at the first agent the three actions. We say and instruct that we have three replicas of this agent reasoning, spanning from a radio access network expert to 5G core network expert to transport network expert. We expect all the outputs to split, let's say, this high-level intent into three expert-specific outputs, and we aggregate the response in a characteristic, or you will see later on. This aggregated response from these three experts are now fed to a more capable agent, the second one, which has more reasoning capabilities. And this agent would perform or would operate as an end-to-end 5G engineer, trying to extract programmable and machine consumable information this time. And this is fed to another characteristic. And at the end, so as to also inject actuation within, because until now we have only reasoning, we use the same agent, but now we prompt it to actually propose some products or some services that would realize this intent and this machine readable information and return the IDs and the names of these products. You may understand that this is an indicative example. It does not perform orchestration, but this was prompted not to perform orchestration. It was explicitly say that do not perform a service order. So if we wanted, this proposal or this product proposal would be materialized in real orchestration actions. And let's see the output. So you can see that the first characteristic is a combined response for domain expert agents. You may try to distinguish radio, core, and transport parameters. The second would be a response of end-to-end 5G network agent. And as you can see, it's a JSON and return JSON that it is machine consumable. And the last agent that actually integrated MCP tooling to derive towards these IDs and names. These are real products of an OpenSlice catalog. This agent can act as an end-to-end B2B sales proposal agent that proposes specific realizing products that would fulfill this high-level intent. So this is the POC that we have until now, but stay tuned because we are preparing something that it really makes sense in terms of network orchestration. Okay, so enough with the AI part. It is fascinating, I know, but we have to be pragmatic and actually augment the realizing part. AI is good, it can derive and extract intents, but if you do not realize it in the southbound API and interface, then you can do nothing. So what we have added towards this throughout this release cycle was a new controller named Gitter, and as the name suggests, it offers asynchronous information exchange based on Git. You will be familiar with it, most probably. So its aim is to replace traditional APIs, imperative APIs, and message brokers, and offer a communication models also in air-gapped systems, which didn't need to have, let's say, distinct integration points. It is built on the principles of Kubernetes operators and custom resources, and it is based on the GitOps model. So what does this mean? We assume that we have a repository and a schema. The producer of the initial request or the initial committer, which is the Gitter controller, writes only the spec field of this schema. Spec field, let's assume it the field that indicates what we want from this schema or this repository. The consumer, which now reads what the Gitter committed and consumes it, will materialize it because they have a contract to understanding the schema, and writes and commits only in the status fields. So the status fields now are parsed by OpenSlice. So OpenSlice can know that indeed the initial request is fulfilled or failed. The Git repository remains, as you may imagine, the cycling source of truth, and the status changes of the Git repository is now translated to TM Forum ontology. If you're brave enough, we have also an introduction paper that tries to introduce this model, and we are invite you to read it. So how you can configure it? Let's imagine an example schema. So this is CRD. I don't think that it is much distinguishable, but let me guide you through this schema. It is a simple custom resource definition that enables or tries to deliver a VM through a Git repository. The spec requires the user to input VM parameters like CPU, memory, image to use, and the power state. And the status spec and the status fields are updated by the external system, prompting about the state of the request. So you have to configure the Gitter controller to be acknowledged of this schema, of course. So he knows what to expect, it knows what to expect and what to commit. And also you have to map the TM Forum states, available, acknowledged, unknown, to the actual schema states, because the consumer or the external service may need to say that the operation is healthy. So you have to know that healthy, in our words, means available. And when this happens and the configuration is set, you initiate the Gitter controller and a TM Forum artifact appears. This is the resource specification of this example custom resource definition in OpenSlice. For you that you are aware of this, specifications are the recipes or the blueprints that you can use to create services upon. So you design a service that you want to expose to the user using this specification, and you expect that someone would order the service inputting the parameters that are requested, CPU, memory, etc., etc. When this happens, the service order is captured and initiated. It is handled by the orchestrator. It understands that it is a getter controller process as it references the respective resource specification, and it commits to a repository, committing, as we've said, only the spec fields. Then an external consumer reads the spec fields, undergoes its process, and at the end of the day, commits at the status fields. And this is then mapped to OpenSlice Team Forum service order. And as we can see, the order is completed. So this is the cycle. This is a typical cycle of service order delivery in OpenSlice, but now it just offers GitOps-based operations as well. Now the second controller. It is based around Nokia's Network as Code platform. Nokia introduced this platform. This is an internal platform used by Nokia to try to abstract network complexity. So it exposes 5G resources in a more abstract way. You can perform actions on these 5G resources, and you can define KPIs and retrieve, of course, KPIs out of 5G functions. So what we have done here is wrap around a provided NAC Python library. Just bear in mind that this is proprietary software, so you have to own the library that comes with the NAC platform by Nokia. You can authenticate with this through our controller. And what we have done is create a REST API around this library and a NAC controller that consumes the REST API, and it follows a pattern of generic controller as we have it in OpenSlice. If you don't know what this is not a problem, because what this does essentially is it connects to the message bus of OpenSlice. It listens to specific queues based on NAC functionalities, and it uses, when triggered, it uses the created REST API to communicate with a NAC instance, and then synchronizes the NAC resources. We have a demo coming in the next slide. So the process, just to get on board, would be that when you have this NAC controller enabled, you will synchronize exposed NAC resources, and this will be offered in the OpenSlice UI as TM Forum resources. You can use these specifications and blueprints to design services, offering them as a service manner to the users. The user can request and check out towards the service. For instance, here, this is a service that we request for a specific IMSI or a subscriber to subscribe to a new quality of service, implicitly implying that we will have a slice change, a network slice change. And then when the order is completed and all the services are active, we expect that indeed the subscriber will be attached to a new quality of service, and as I've said, implicitly to a new slice. So let's see how this happens. As we've said, the UI synchronizes several NAC resources. These are categorized by type, as you can see, state and operating date. And then a user would design NAC-oriented services around these resources. Let's imagine that we have indeed to design a service that offers the IMSI in QoS functionality. So you have to reference the synchronized resource, and then you have to design a so-called customer-facing service, which will enable the user to actually input the characteristic he or she wants. In this case, we want to accept which IMSI will be altered and which QoS profile will be used. Typically, you expose the services in the service catalog, and lately you can also trigger it via the AI assistant as well. You defined the characteristics, the configurable characteristics, IMSI and QoS profiles, and indeed, when the order starts fulfilling, you may see that new resources and services are created. Eventually, the order will be completed, and we shall see that it created specific services which are on active state. This means that this will create a new underlying resource, and as you can see, it indeed puts the new IMSI in a new QoS profile, which is gold. This is the CLI of the NAC itself, so to validate that this action indeed happened. Now, if you tear down the service, of course, this will deregister the specific subscriber and return it to the original state or the original QoS profile. Okay, so enough with AI and controllers, and I would say the technical side of this release. And let's go towards the business world. So you may imagine that from the presentation up to now, there is a gap between commercial products and this functionality, controllers functionality. You may also know that modern operators operate at business logic level, so they try to expose products and federate marketplaces and exchange that said products. And indeed, until now, OpenSlice supported TM Forum product layer in terms of an API substrate. So you can browse catalogs, product catalogs, you can issue product orders, but the UI actually lagged behind. So what we did in this release was to augment the UI to offer also a prototype BSS. There are some bullets here that you may see, that they may seem a lot. So what is a product specification? What is a service specification? What is a product offering? So instead of trying to explain this in bullets to initial them, this time, let's go with a demo on an actual environment, a production grade environment. So this environment, this is the same environment that we used for the AI assistant. But this time, let's go to the BSS side of this instance. So as you can see, we have an empty marketplace. We have nothing here, but as you saw, as you've seen earlier, this has many technical functionalities in terms of services to expose them. Let's imagine that we have to offer a product of a private 5G. I have to sign in again, as it seems. And assuming that this service as functionality is already existing, because it is now, we have to make and bring this functionality or this technical specification into the product world. So what we do is to try to create the product family that we want to offer by product specification. So we create a new specification, let's call it private 5G, by the family that we have to support, and we submit it. So this is a new family created. Now you have to reference or you have to link the two words, the services, the service word, which is the actuation, and the product, which is the marketing word. So what you can do here is assign the functionality that you want to offer. For instance, here, let's assume that this is the connectivity, the realizing service that would bring forward the 5G connectivity and internet access, and we bind it. So what this window prompts here is that it says to us, to the product designer, that this service or this realizing concept of 5G connectivity offers some configurable parameters to the user. And it prompts us if we want to import them to this product family. I mean, it makes sense to import them, but we can live without them. And the parameters that are actually here are the ones that you can see in the screen. You can define radio nodes, you can define radio profiles at these nodes, and you can see some characteristics of MCC, MNC, and TAC that are a bit contradicting if you are familiar with this. So RAM profile and 5G radio profiles are for a simple user, okay? It can, he or she can select radio nodes, but shouldn't be able to enforce MNC and MCC changes, as well as track area code changes as well. So we have to differentiate between two product offerings. To do so, we have to create subsets of this private 5G family. So we go with a product offering, and we create private 5G. We bind it to the private 5G families. It copies the properties of this family. And here you can select, after you submit, which characteristics or which parameters we want to offer to the user as configurable. So this is a simple user product. So we'll let the user select RAM profiles, and we will only offer, let's say, 2 RAM profiles to the user from the actual 5. Okay, and we will let the user also select radio nodes, but we would need the user to select only indoor radio nodes, for instance. So this is what we do. Okay, and we just create it. This is a user-oriented, basic user-oriented product. Let's do the equivalent for an administrator. So we go to the product offerings again. We have to create a new product offering. We have to inherit the same family of products. And this time, we will select everything because admin can do that. So we can select all the characteristics. We have to select all the values of each characteristic. And now we are ready. So at the end of the day, we have to see a marketplace, right? So the marketplace is again empty. And now it's the time to expose things. So I think the most binding, let's say, category would be the wireless connectivity. Of course, you can augment the catalogs, categories, as much as you want. So let's see the product categories, go to the wireless connectivity, and attach these newly designed products. Actually, I forgot to name something differentiating, like an admin one. So bear with me. But we will understand it from the characteristics. So now, indeed, the products are available. We cannot see which is which, most probably, but by previewing them, you can see that this exposes only 2 characteristics, that this is a simple user private 5G. So we can place it in the order list, and the user indeed can select from the indoor nodes and the radio profiles, the one selected. We can issue the product order. So this is here. And let's assume that we are an administrator now, and we have to select the admin side service. This is the one. Imagine that it had an admin name here. And on the same manner, we can select configurable characteristics. See here that we have another option as well. And we have also default values. And that's it. So from this side, as I said, this is a production environment, and indeed I don't want to initiate, let's say, product orchestration here that would result to a service orchestration. But you have seen it many times, even today. So when the state is changed and acknowledged by the administrator, or it can be automatic, it issues the respective service order, and the product is realized and fulfilled. Let's go back, and bear with me, we are almost done. So, okay, this is business BSS functionality. We have controllers, we have AI, but we wanted also to augment a bit the observability. As you may know, or you may have experienced in the past, the Docker Compose installation includes Portainer. It is a platform to offer observability in a Docker Compose environment and monitor the overall health. It provided logging as well, so you could track the OpenSlice installation. This is for the OpenSlice maintainer or the infrastructure admin, okay? we want to have an equivalent solution in Kubernetes installation as well. We would assume that the Kubernetes that hosts OpenSlice would already have specific contemporary monitoring tools. Although these tools are not OpenSlice specific, so they do not offer OpenSlice specific metric or OpenSlice meaningful metrics, but they target the whole cluster. So this release brings forward a new observability solution, a new dashboard in Kubernetes, which is independent on the Helm chart. You can opt in or out of the observability stack. It relies on battle-proven components for monitoring. So it is based on Prometheus, Grafana, and Loki for log parsing. And it offers an OpenSlice-oriented dashboard that aggregates the deployment metrics and logs. So let's see an environment that actually will demonstrate this. So this is the observability dashboard. We made it deliberately fail or actually aggregate errors, as you can see here. This is an instance that we made it so to showcase this dashboard. So what happens here is that we start with the overview. We can see how the whole instance is doing, or the cluster is doing in terms of OpenSlice. So you can see the CPU usage, memory. You can see the CPU pressure, memory pressure per node. Then we can see the memory usage per OpenSlice component. You can see the CPU usage and the disk usage respectively. The network usage as well. Of course, you can always filter per component. And here is the OpenSlice namespace summary. We can see that the number of pods that are running, the number of deployments, the replica sets. We can see the pod states, the number of restarts. So this is an overall, let's say, dashboard for the OpenSlice namespace. We can see the resource saturation, which when we have an unhealthy pod, not the one that generates errors, and a healthy one, we can see what went wrong here. And last but not least, we have the log overview. So we can see that a top, let's say, top error producing components. In our case, this is one. This is the error trend. And as we can see, we have a specific interval here that this error appears. And it was made on purpose because this component tries to connect to a specific Kubernetes cluster. And because it cannot find it, it fails and it tries in specific intervals. This is the reason for this pattern. So we can understand if it is, I would say, an exceptional error, or it's something that it appears in patterns. And of course, there is this logging that you can have for the whole namespace. So you can trace things. You can trace, for instance, errors. Maybe perhaps it's not the case. What's happening here? Let's see. Demo effect. Let's see. Doesn't appear to be responding. Let me refresh it if it is the case. Okay, now it's fine. So this is a log pattern. So you can search for errors, but not only errors. For instance, you have to track a specific service order fulfillment within the logs. And this order would pass through several components. So for instance, for traceability, you can track a specific order here and see which component it passes from. So you can trace logs, you can roll back, and you can distinguish problems. If you do not filter with a log pattern, you can see everything. You can see which components generates what. So this component is OpenSlice awesome. This should be, I guess, Nginx, Portal Web. Or you can filter by component. and get only the component logs. So that's it regarding observability. And this is my last slide, and I give the floors to the other speakers as well. As we've said at the beginning of this presentation, we have noticed and have been reported by new users that OpenSlice indeed has a steep entry barrier to newcomers. Because when you install OpenSlice, it is empty. So you don't have anything to play with. We offer typical service design and deployment examples of employing controllers. So the documentation section is offering documentation sections on how to design services to deploy NFV artifacts, Kubernetes artifacts, Helm charts, how to employ monitoring sources, how to employ Camara, Silva, and Gitter. But this would enable, this would require manual labor from the user. And if the user is unexperienced, it is quite error prone. So to accelerate onboarding, we're launching a repository of package service templates. So these templates are aimed to be ready to be deployed with none to minimal configuration. And the one service that we have elected to start with is an indicative 5G deployment within a Kubernetes cluster with simulated subscribers. So when you install OpenSlice and you import this service, you can deploy it almost out of the box, and you can have your 5G environment with simulated subscribers to play with. This packaging follows a hierarchy of OpenSlice native paths. So it can be imported by using a functionality, an import functionality and utility. It's just a Docker command that imports this package within your OpenSlice instance. And this repository will be updated by the community, offering more and more custom blueprints, so for newcomers to play with. Unfortunately, I had a demo here, but due to some unexpected last-minute errors, given the fact that this release was actually live for a week, we have a bug that is not always reproducible, but we have to fix it if we're saying about the release and before we show you everything. And we are expecting to fix it in the upcoming week and update the respective wiki pages so you can do it on your own and prove that indeed it is newcomers friendly. That's it for me. I think I monopolized the conversation so far. And the floor is to Rafael now.
Okay. So first of all, good morning, everyone. My name is Rafael Direito. I'm a TSC member at the SDG OpenSlice. And as you know, Kostis already introduced some of the controllers that we have created in OpenSlice. But now I will introduce one that was not actually addressed by Kostis. So this presentation is about offering Camara APIs as a service. And basically, to enable this, we have created a Camara controller in OSL in OpenSlice. Let me start with just some context on 5G networks and on Camara. Okay, so I believe that most of you are aware that 5G and beyond 5G have enhanced network capabilities. So now we can have ultra low latency scenarios, higher throughput, etc., etc. But one of the most important advances introduced by these networks is the high level programmability and control that we can have through their control planes. And in this sense, these future generation networks, they support various use cases for vertical industries because they allow to create tailored solutions for specific industry requirements and allow applications to interact with the network in order to enforce specific capabilities that are desired by the applications to work in an optimal manner. However, even though it is very interesting, the interfaces that are exposed by the 5G and beyond 5G control planes, these interfaces are really network driven. So if you are from the software world, for instance, someone like me, it will be very difficult for you to grasp these APIs and to be able to use these APIs for you to create an application. So developers most often require to have network expertise in order to interact with these networks. And of course, that this impacts the development of innovative use cases, and this slows down innovation. Now, how to address this issue? So one initiative that aims to address this issue is the Camara initiative. Okay, so this initiative was initially coined by the Linux Foundation, and the Camara initiative aims to create a set of very simplified and straightforward APIs for you to interact with complex network functions. Okay, so the idea is to enable developers to access advanced network capabilities, but in a straightforward manner. But imagine that you are a mobile network operator or a CSP, and you already have some services on your domain that you use to achieve a given operation, for instance, to enforce QoS profiles. Now you have the Camara APIs, and you want to expose your existing services, but through these new APIs. And when I talk about Camara, we can have other initiatives that offer new interfaces. So what happens when you have a service and you want to offer that service, but through a novel interface? So I don't believe that the ideal approach is to be rewriting all your business logic, all your charging and billing workflows and mechanisms. Okay, so probably it would be best to reuse what we have and expose it in a new manner. So basically offer the same functionality through a new interface, but without a lot of modifications to your underlying systems. So let's now delve into the current landscape for network operators. So as Kostis said, and the same happens with OpenSlice, various MNOs are adhering to TMF's Open Digital Architecture, or TMF ODA. So ODA provides some workflows and frameworks in order to achieve digital transformation. But more than this, it provides various open interfaces, various APIs that allow for operators to expose their products, their services, their resources, and also to manage their lifecycle in a standardized manner. Okay, because basically TMF specifies these interfaces, then the MNOs adopt it, and this way we create a unified management layer. Okay. So when we want to offer an existing service, if this service is already aligned with the TMF or the concepts and is exposed through TMF APIs, why can we not use these same APIs to expose this service in a different manner? So why can we not use middleware translation layers that translates the requests that you receive on your new interface, in this case Camara, and then maps these requests to TMF APIs that interact with the actual existing service? Okay. We'll showcase in this presentation. So we assume that we are an MNO and we have a QoS profile enforcer for 5G UE. This service is already onboarded in a TMF or the aligned OSS, in this case OpenSlice, because it has all the workflows and all the APIs from TMF Open Digital Architecture. And when we want to manage the QoS profiles of our UE, we simply interact with OpenSlice. We change some of the characteristics of this service through a TMF API. And when we change the characteristics, we patch the characteristics, we have a controller that will gather the changed characteristics, and it will enforce the operation that we have actually requested. Okay, so this is our starting point, which is what I'm showing here. So we have a UE QoD profile enforcer, so a quality on demand profile enforcer. The service is already exposed through TMF APIs. It's on OpenSlice. We can configure it as you are seeing here. We can configure the various QoS profiles it will offer. And we have ordered this service. And now let me just show you how we can interact with this service. So here we have a vast collection of TMF service characteristics. And as I was saying, if we want to request an operation to our network, we can simply interact with the service by patching its characteristics. So here on the right, you are seeing 5G UE at IT Aveiro's facility. And when we order or when we configure a UE and we provision it, the default QoS available in this UE is of about 10 megabits of uplink and downlink, which is what we are proving now. Let's say that I wish to enforce a new QoS profile on this UE just to reduce the throughput that it has access to. So I can simply change the characteristics. So here we input a unique identifier and we ask our service to enforce the low QoS profile. Okay, and as you can see, the throughput was reduced to 2 megabits of uplink and also downlink. So we have this service. This service is working as expected. We have implemented charging policies, billing mechanisms. Everything is implemented, but now we want to expose this service through the Camara QoD provisioning API. Okay, so I have already spoke about creating middleware controllers, and in this diagram here, you can see how we do that. So we can create a Camara API middleware controller, which is nothing more than a simple translator. Okay, so we then can order this middleware controller or this translation controller, and we have to reference the original service that will be exposed through this Camara API. So after ordering this service, the Camara middleware controller will result in a Kubernetes pod and a Kubernetes service just exposing the Camara QoD provisioning REST API. And you will have the URL on which the Camara API is exposed. On OpenSlice, you can get all the information about this service in OpenSlice through also the characteristics, as Kostis has also demonstrated before. So if you go to OpenSlice, you'll be able to have this URL, and you can disseminate this URL and offer it to your clients. So now your clients, if they want to enforce QoS profiles, they can simply use the Camara API that you have ordered. When your clients make a request to this Camara API, the middleware controller service that we have implemented will render all the information that is available on the payload received by the Camara API, and it will map this information to TMF characteristics patches. So it will patch the characteristics of the original service, of the service that already exists in your infrastructure. When this takes place, your original service will continue with its life cycle as we have demonstrated before. It will enforce the QoS profile as requested, and it will then expose information just stating, well, on the status of the operation that was requested. So after that, the Camara service will become aware of the status of the operation, and it will expose this status through its REST API. So your client will be interacting with an already existing service through a Camara API, and the client won't even know what's happening behind the scenes. The Camara API is working, it's providing the information, it's receiving the requests and performing the operations that the client requested. Okay, now just some brief demonstration. So as I said, the first step is to get the unique identifier of the service that we wish to control through our Camara middleware service. So yes, just capturing the unique ID, and now we will order the Camara as a service middleware. As you saw, we have referenced the original service, the already existing service. We will now acknowledge this service order, once the order is completed, information on the just deployed Camara API will be exposed through the MF characteristics. So you can see here that you have this URL here. You also have some usernames and passwords which are not applicable. And after this, you can provide this URL to your clients just here. Okay, you can simply use this URL enforcement of QoS profiles by leveraging your already existing service. So now we will once again enforce the low profile. As you can see, the Camara API is responding according to the defined schemas by the Camara initiative. We can even query the status on the provisioning, the QoS provisioning that we requested. We will have all the information, and this is all that your client will see. Okay, just this Camara REST API. We can see that the QoS enforcement was requested. And in the backend, what happened during this process, and as I have already said, is that our middleware service patched our existing service, as you can see here. Okay, so these characteristics are aligned with the payload that was received through the Camara API. Now our already existing service will conduct the operation that we have requested and that we have demonstrated before. And now you can see that there are some results. Okay, so this characteristic here we had to introduce. So it was just one small modification just to synchronize the information between the two services. Okay, so this was the only modification that we did in our original service. And you see that the Camara middleware already captured this information from the original service, the status. And if our clients use the API once more, they will see the status as available. Okay, so this way we have offered a Camara API without having to re-implement all the logic and the workflows that we have on our already existing services. So this is a new way for you to expose your services with minimal modifications. So here we have used Camara, but Camara is just an example. You could have other APIs. Okay, if tomorrow there is a new API that is provided or specified by a different organization, the same process will apply to what we have showcased here. And we have disseminated this work into publications, one demonstration at Infocom, and also a magazine paper in IEEE communication standards. And tomorrow I will also have, I will be presenting a demo in the demo booths. So if you want to get more information about how we are exposing already existing services through novel interfaces with only minimal modifications, just pass by and, well, we can have a chat. And with this, I think that my presentation is done, so we can move to George.
All right, good morning from my side as well. My name is Yoros Katsikas. I'm also a TSC member in OpenSlice. This is the last presentation of this session, and I'm going to talk about how we can enable collaborative and multi-actor marketplaces in OpenSlice with a new feature. Oops, that's not a good sign. So today's landscape is really complex, with the cloud computing continuum expanding towards the extreme edge. So it creates a massively heterogeneous multi-domain context where we have multiple stakeholders doing business on top. And this is where environments and platforms like OpenSlice become handy, because they try to abstract the underlying complexity, exposing resource as a service, and therefore offering sector-specific marketplaces to those stakeholders. The question here is, how can we enable business among all these players? Because we have common markets in some cases. So marketplace federation is becoming important in this case, but there are also challenges to address. So imagine a case with one stakeholder who have already developed service in their domain. If we go by the OpenSlice approach using standardized APIs and data models, this stakeholder can describe those services as specifications via TMF, so create service blueprints, add those in a catalog, so create a kind of a marketplace, and then expose the marketplace in a point of presence. If we repeat this process across stakeholders and assume that everybody uses the same standardized way of defining those services and then exposing those services, then we create a standardized ecosystem of services where everybody uses the same language and data models. This is the foundation for sharing the marketplace and making the marketplace federated. So an essential tool for making this happen is what we call peering of orchestrators. And we will showcase this by a specific way of peering the service catalogs among different OpenSlice instances. So this is a revisited feature in this last release, on which we worked upon. And let's see a very simple example how this is working. So assume two OpenSlice instances which have their own services in their catalogs. The owner of OpenSlice 1 or user, whatever, comes to OpenSlice 1 instance and says, I want to order services from OpenSlice number 2. How is this going to happen? We need to synchronize the two OpenSlice instances. So we need to find a way to import services from the remote OpenSlice. This is supported via TM Forum version 4 APIs using the party management API specifically. And then this way, we are able to pull this Kubernetes as a service, which resides in OpenSlice 2, into this OpenSlice 1 instance. But then suddenly we come to a situation where we have two identical services in the catalog with the same name. So how can we discriminate? The way is basically to make those specifications kind of location aware. So to be able to easily discriminate what is what. So what we have done here is we use some annotations in the way we do the peering between the two OpenSlice instances to somehow map different catalogs and services to different OpenSlice instances, therefore create expanded marketplaces. In this case, what we have done is we create specific catalog, category, and specification for these imported services marked with a prefix. The way we have done this peering is actually by using a prefix to discriminate between what is a catalog, category, and service coming from OpenSlice 1 versus 2. And the way we would like to do it eventually is also use location-specific information about where this OpenSlice 2 might be. So we want to leverage geographic APIs by TM Forum. At this point, we have stumbled upon a kind of a blocking point where we found that there is a missing critical documentation in those APIs so as to finish the implementation. We have raised this issue in TMF, and we hope that this will be eventually resolved so that we can finish, let's say, this feature, adding also location metadata in the way the peering works. So another thing that is important while we're doing this peering is what happens if the opposite, the remote OpenSlice goes down and suddenly this Kubernetes as a service, for example, specification that we imported previously is no longer available. This way, we need to introduce also mechanisms to ensure availability. And in the case that something goes down, be able to use some heartbeat mechanism to identify this let's say, unavailability of the service on the other side. And therefore, in the same way we created these catalogs, categories, and services, be able to delete it as well, so that we avoid any kind of confusion from the user to order something that is no longer available. So let's now see how this simple but extremely important feature goes in action. We use the Copilot project as a good, let's say, example for applying this peering here. This is one of the largest innovation action projects to date, which manages 5 different vertical sectors in Europe: mining, smart cities, agriculture, energy grid reliability, manufacturing, recycling, and so on. So we have really a really heterogeneous system here with domains expanding across the whole Europe. This is a kind of a map of Copilot to showcase the European scale of this project. And wherever you see a pin on the map, it's a potential OpenSlice instance to be created by the stakeholders of those Copilot clusters. So you see how this environment gets really complex eventually. In each of those Copilot clusters, we have applications to be deployed and developed that should collaborate with each other. So every stakeholder using OpenSlice here wants to introduce his or her own application and allow this application to interact with others. But this environment is not a full mess, let's say. So we cannot use a single OpenSlice to be the master, so to say. And we need to introduce some higher entities on top so as to promote, let's say, a pan-European marketplace. And for this to happen, we had this need basically to create this marketplace and expose it from a single portal. So what we develop on top is additional tools on top of OpenSlice, which allow to expose this as a federated marketplace. And in this case, we use a kind of a hyper orchestrator, which we call Maestro, which binds with those OpenSlice instances the way we have showed already with a peering feature using TM Forum APIs. And there is also an underlying network fabric, which allows to expose those OpenSlice in an encrypted manner, so in a secure manner, in other words. So we created all this big fabric in Copilot, and today we have 7 OpenSlice instances available across Europe, and Maestro is peering on top of those. So I'll show you 2 quick demos how this peering works through Maestro, through a single portal, and then eventually how this Copilot marketplace has been actually formulated today using the foundations of OpenSlice and this peering feature. So let's go to the first video. Okay, this is the portal of Maestro, and we start with a map of Maestro showing OpenSlice instances in Europe. Just to showcase how this peering works, we have not peered every OpenSlice in this demo. We've peered a few of them, like 2 in Greece, 1 in Sweden, and we're going to show you how to peer another one in Spain. So the target OpenSlice to peer is in Valencia. Here we show this underlying network fabric, so the network attached to Maestro to do this secure exposure of OpenSlice. And here you see the available OpenSlice instances already peered with Maestro. So we have 4 of them available, and we're now going to add a new peering. So for this peering to happen, we need to introduce a name for this new OpenSlice instance. This is for cluster 2 in Valencia, so in UPV. For the peering to work, we need credentials because Maestro hits an OpenSlice API, which is an authenticated API. So we add some credentials here for Maestro to access OpenSlice. We also need an authentication token for this transaction. And finally, we need, of course, the IP address and port of this OpenSlice instance, which is available in the city of Valencia. And we also add an address to be able to create the respective icon on the map. And the peering begins. When the peering begins, we get a list of all the available OpenSlice service specifications in this instance in Valencia. So you see the list here. And the user has the ability to actually create a dedicated catalog and category for those services to be injected there. So we use a catalog CL2 Valencia Smart City, and then a category, which we're going to call Smart Resource Management. And then we pick the desired service specifications out of this list. One is waste collection alerting, and the other one is Smart City Event Management. So 2 service specs should be peered. And when we do this, we see another OpenSlice instance being created here. And if we go at the map, we also see the respective icon in the area of Valencia. Now, if we go to the marketplace of Maestro, we see this new dedicated category, CL2 Valencia Smart City, with a new category, Smart Resource Management. And if we click there, we see the two service specifications, Waste Collection Alerting and Smart Event Management. Simple and useful feature. So the peering is really a matter of a couple of steps. And now if we repeat this for Copilot a couple of times more, so as to create the whole marketplace, we go to the other video to show you how this marketplace has been established today using this peering feature. Now you see the map of Copilot like in full. We see several OpenSlice instances in Greece, one in Valencia, one in Portugal, and one in Sweden. Let's begin. So we go again to the same view to showcase the underlying network of Maestro, which is this secure integration fabric, and then the available OpenSlice instances that are already peered. Here we see one for cluster 1 in Sweden, the one that we showed earlier for Valencia case, cluster 2, and 4 for cluster 3 in Greece, and a 4th one in Portugal for cluster 4. So we have 7 in total. There is also a central one which is used for management purposes. And now if we go to see the full marketplace with a full set of services being peered and synchronized, we see one specification in Sweden, the 2 that we showed earlier for Valencia, 3 of them available for the agricultural cluster, 1 in each category. Another 3 services for the energy grid, and finally 1 available service for cluster 4. So this is how the peering has been done in practice, in a real example, in a large-scale project. And of course, this is an ongoing work, so we're going to expand this marketplace with more services, more use cases, and even more OpenSlice instances in the future. So that's it. Let's go back to the slides. I'm going to just do a spoiler alert now to close the session. Maestro is a proprietary platform, has been proprietary platform so far, but since January 14, it's becoming an open source tool under Etsy OpenSlice called Hypo, out of Hyper Orchestrator. Ubitech is leading this MDG, and Tata Communications is also participating with the extension of OpenZT underneath Maestro. So this is a new exciting journey for especially for us, who are going to see our developments throughout the years to materialize in an open source tool. And this also nicely expands the OpenSlice ecosystem with new features, especially for creating mesh, let's say, topologies of OpenSlice instances. So we're going to see more about this today and tomorrow with other demos available. Thanks.
Thank you also. Apologies for a slight delay. Thank you for your attention. Hopefully you found it as exciting as we did preparing the slides. I'm not sure that we have time for questions now. Maybe one, if you have some. We will be around anyway, so you can, of course, contact us. Any quick questions, or you are running for coffee?
One quick question. I think you showed about that Nokia's network as a service. In this kind of thing, how do we ensure that there is no misconfiguration by an amateur developer? So these libraries are much more controlled and all that.
Mm-hmm. So this platform, just to begin, is proprietary. It's not offered as an open source. We just offer the wrapper around it. So we expect the user to own the library. We don't have any I would say, ownership over the actions. We trust that indeed this will happen, but this is a declarative actually approach, because we don't contact NAC platform, Network as Code platform, to execute an action and we expect a result in an API call, for instance. What we do is execute a command towards Nokia Snack, and then we synchronized again the resources. So eventually, if this command is correct, we will also see in a parallel process that this new resource that we want to create is synchronized. So this is how we ensure, at least, that we have a loose coupling between those two platforms. And if we have, let's say, a failure scenario in between the communication, eventually this will be surpassed by this.
Thank you.
I have a question about the camera project. It seems to me that it's very complementary to the OpenCAPIF. I guess this is not a surprise. My question is more about how those two groups actually cooperate.
Actually, let me answer something, and then, of course, we can. It can be complementary. I wouldn't say that these are identical in terms of, for instance, Camara is, let's position Camara. It is an application, let's say, side initiative, okay? It is exposed towards application users. We've seen yesterday, for instance, Camara in OpenOP presentation, a user interacting with Camara, which translates to the network exposure request. So through a transformation function. So that's one way. In our scenario, we offer Camara as a service, also passing through the billing process, because we have to monetize out of it. We cannot have a network that actually everyone suggests, I want the perfect quality of experience. Okay, so we go through these TM-Forum APIs that we expect that the operator would already implement in this ODA architecture, business product and services. And this is how we close the cycle. Now, OpenCAPIF will come into play if a realizing service would need to interact with the 5G core itself. So when you ask, for instance, not the quality QoS enforcer, but you may ask for the location, UE location Camara API, you need to have metrics from the NEF. Now, the 3GPP standard to conduct NEF as an external stakeholder would be to go over OpenCAPIF authentication. You go to OpenCAPIF, you request a token, this token is refreshed, and with this token, you onboard an invoker in OpenCAPIF, and you actually invoke the NEF. So this is how we see that these two can be integrated. And as a matter of fact, this day, later this day, we have a cross-SDG demo that we host a demonstration between OpenSlice, OpenCAPIF, and Eurecom's NEF. So what we do is trying to abstract the CAPIF flow, which could be quite, I would say, stressful for a newcomer. You have to authenticate with a CAPIF service, you have to request a bearer token, you have to retain and refresh this token, and we just offer NEF functionalities, abstracting the CAPIF flow. So I think we can move this conversation there as well. I don't know if you're covered, but maybe Rafael can augment this answer.
No, I don't know if Kostis answered your question or if you have any further question. Okay. So I think it's time to go to.
Okay, thank you very much again, everyone.